everybody. Hi everybody, this is Mr. Jones. Today we're going to have a look at naming compounds and also how to write the balanced chemical formula when given the just the name of the compound. And as you can see, we're going to look at our objectives for today is going to be naming ionic compounds, naming covalent compounds, some tricky rules with transition metals and Roman nomenclature, as well as some tricky rules with polyatomic ions involving oxygen, and writing chemical formula given the compound name, as I said, and doing some revision on things like valency and charge, and identifying charge of the element to determine the number of atoms. So we will look at some revision as well in the next slide. So just to revise valency and charge, we remember that the group numbers indicate to us the valency. So in group 1, we have a valency of 1. In group 2, we have a valency of 2, and so on and so on and so on up to group 8. Now valency, remember, tells us the number of electrons in the outer orbitals. And these are the electrons that are involved in bonding. To make things clear when it comes to the relationship between valency and charge, because we can see that valency can determine charge. We need to look at something called electron configuration. Now, with electron configuration, it's nice nice and easy to try and visualize it. So as we did in grade 8 and grade 9, your drawings of the structure of an atom can really help you to understand electron configuration. So let's take lithium as an example here. So we see the atomic number, or the number of protons in lithium, is 3. So we know there's 3 protons, positive protons, in the nucleus, as well as the neutrons. And then we have 3 electrons as well, don't we? Because it must make a balanced element, or it in the periodic table they're represented as neutral elements. So we have 3 electrons, and in the first orbital we have 2 electrons, and in the second orbital, let me change color here to blue, and in the second orbital we have 1 electron. Now when it comes to electron configuration, this first orbital closest to the nucleus is known as the 1s orbital. The second orbital is known as the 2s orbital. And a rule with these s orbitals is that they only have, or can only possess, 2 electrons. Now, as we can see, that lithium has space for another electron to be present in the second orbital. But remember that metals like to give away electrons. That's an important point. They like to give away electrons. So in lithium's case, this electron will be given away during a reaction. So let's have a look now at how we would understand the charge based on the electron configuration and the valency. So here we have a valence electron, or one valence electron, based upon its electron configuration, and we know that metals like to give away electrons. So the charge that it will form will be a positive charge. And how can I say that? Well, let me show you. So lithium, in its 1s orbital, it has 2 electrons. In its 2s orbital, it has 1 electron. Now we know lithium is the metal and it likes to give it away, so if it gives this electron away during a reaction, how many electrons are we now left with? We're only left with 2 electrons. And in our lithium atom now, our electrons and our protons are now not balanced. So we have a total of 2 electrons and 3 protons. So our overall charge is going to be positive. So as long as we can understand that, our valency will our electron configuration determines our valency. Our valency will determine our reactivity, and the valence will also therefore determine the charge that the element takes during reactivity.